All right, so we're on lesson 3.1 for the geometry. We just got done with our warm-up. We're going to do some notes. We're going to talk about some stuff that we have known from before and hopefully add a couple things in there that you don't know. First one that you guys probably, most of us should know is parallel lines, okay? The official way we're going to define this is two lines that do not intersect and are coplanar, okay? Always before we've said two lines that don't intersect, right? You know, they go on forever and ever and never touch. But that's not the exact definition of it. I know it's exactly what we think of when we hear that, but it's not the exact definition, all right? So two lines that do not intersect and are coplanar. What does it mean to be coplanar? Same plane, and a plane is like a piece of paper, right? So if you can put those two lines on the same piece of paper, then it's coplanar. Right? And it's parallel. Example of that is like railroad tracks, right? They're on the same ground, they're flat, right? They're coplanar, they go on forever and ever and never intersect. You know, I know they curve eventually and they have the, you know, track, will touch in some way, but, you know, for short distances. So anytime we can draw two that are coplanar and never touch. Skew lines are probably one that we're adding to our vocabulary. Those are two lines that also, they never touch, right? But they're not coplanar, okay? So an example of this, right? So if I have one line right here going this way like that, and then we draw a second line over on the chalkboard like that. So I have two different lines. Are they in the same plane? Would they touch if I extended them forever? No. I mean, the only way they would touch is if I had them both pointing at the same point, like up there, right? That's the only way they could touch. Are they parallel? Definitely not parallel. I mean, they're not. They don't even look the same, right? So those are called skew. Different planes, still they don't touch. Right. Last one I have down here is parallel planes. That's the same as parallel lines. The only thing is we're talking about parallel planes, right? So we're talking about big, flat pieces of area that don't touch each other, okay? Even if you extended them forever. Can anybody see an example of parallel planes in the room? Nino's pointing at the back wall and the front wall, right? Those won't touch if we go on forever, right? They're parallel. They're not lines. They're planes. All right, does anybody see any others? The sidewalls, right? Where are you pointing at right there, Nino? See, the ceiling and the floor isn't, because our ceiling is angled. Oh, yeah, our drop-down lights and our floor are parallel planes, but our ceiling goes at an angle, so they would touch out over there in Ephraim's yard somewhere. All right? Now, on the bottom here, I have a picture of two lines, right? Are those lines parallel? Yes. Yeah? Yes. You guys know that for 100% sure? Yes. Yeah? Even if I extended them forever, they don't touch 100 miles that way? Yes. They don't. That is brave, man. I wouldn't be so confident in that. I mean, like, they could be getting just a little bit closer and a little bit closer, and they could touch 100 miles that way. And they still wouldn't be parallel. They'd look parallel here. 1,000 miles. Right? Now, the truth is they look parallel, but you don't know it unless you're told. Okay? Remember how we were told that sides are equal in length? Congruent? We're going to do something similar to parallel. Those two triangles or arrows will tell me that those two lines are parallel to each other. Okay? So that tells me that those two lines are parallel to each other. The other way is if they tell you through words, right? So like, you know, before we could use like a congruent sign or an equal sign. Here, I'm going to say M. I'm going to use two like lowercase l's or sticks or whatever, right? Parallel to N. All right, see how those sticks look like parallel lines? So that's another way of being told that they're parallel. All right, so we move on to example 1. We have a box here, a 3D box. And it's got a lot of letters in there and everything. They're going to ask us a few questions about it. Right? They want us to write down what lines or planes fit the description. So I'm looking at lines parallel to CD and containing point A. So I probably need to look at where's CD at. CD is this one here, right? So I want a parallel line that contains A. Yeah, AB or BA, however you want to look at it. So this is, all right. So AB contains A, and it's parallel, right? Because they're coplanar. How about B? Lines skew to CD and containing point A. Which ones are skew and containing point A? I heard AG, which is right. If we look at this one, are those two going to touch? They're not on the same plane, right? Let's see. I'll use this box over here. Okay, so if you look at any box that you have, let me turn it. So this is CD. This is the one we're trying to get to. This would be point A. This is GA. Would that ever touch this line here? No, they would always be this foot apart, but they'd never touch, right? And are they in the same plane? No. So that makes them skew. So I have GA and what was the other one? Oh, sorry. And which one? AH, okay? FG does not contain point A. Yep. That's the way how they reduce it from lots of answers to 2, right? All right. How about lines perpendicular to CD and containing point A? What's perpendicular mean again? They make what type of an angle? 90 degree, right? So I'm looking for 90 degree angles here. Yeah, A, D. Are there any others? Are there any others that are containing point A? AH? AH does not intersect CD. They're not parallel or perpendicular. All right. Now we're looking at planes parallel to EFG. EFG is the bottom of the box. Right? And we want a plane that's parallel to it. What plane would be parallel to the bottom of the box? Yeah, D, C, B. How many different ways could we name that one? I think there's 4 different ways that we can name it. I think 4. Well, there's lots, right? So that was just looking at a 3D figure, coming up with some answers, right? Here we have a picture of, it looks like a town by the ocean, maybe? I don't know. It's tough to tell, right? But those are roads, okay? We want to name a pair of parallel lines, name a pair of perpendicular lines, and at the end we're going to tell is FE parallel to AC. And then I'm going to show you guys where those are because I know they're tough to see. Okay, so some parallel lines. And here maybe I can, all right, so there's, oh, that doesn't really show up very well, does it? Can you guys see that all right? B, M, A. Maybe that helps a little bit. All right, so we want to come up with some parallel lines, all right? And we have 2 triangles on that one, 2 triangles on this one. All right. All right, and that looks like everything you guys need to see. Pair of parallel lines. Which ones are parallel? And D, A is parallel to EF. And then again, it doesn't matter if you switch the names on those, it's the same line. Name a pair of perpendicular lines. All right? And what we want to look for is that little right angle mark. Okay? So on this one, we're looking at DA. From D to, oh, I guess that's an M. My bad. So this would be DM2. So DM, DM. Make a 90-degree angle where? Yeah, right here. But that's M. A's down here. Does that make sense? So this is A's point, and that's M's right there. So that's why I just call it DA, but DA would go from here to there, like that, which isn't right. Right? So I was reading it wrong. Now, DM, now I want to tell them that they're perpendicular. Just like here, we have a symbol for parallel. We have a symbol for perpendicular too. It's an upside down T. Right? You try to make them perpendicular when you do that too. And that other line over here is BF. Right? All right. Now, picture's kind of hard to see and tell what it's asking and stuff, but on C it's asking, is FE parallel to AC? No. How do you, why? Why or not? Why not? So if you extend them, they'll touch, right? I think a better one that they could have asked is, if they would have said, is BF and CE parallel? And I still think it's a no. So it looks like they're going to touch eventually.
Yeah,
a million miles that way.
That's what I was saying.
Yeah. So this one's a no because eventually they will touch, right? All right. Let's see if the next example looks a little bit better than that. We're going to talk about transversals. Okay. A transversal is any line that cuts through two or more other lines. Okay. So I drew a picture there. The transversal cutting through two lines. The transversal one here is the one that's going vertical. But I want to know, how many angles does a transversal make? How many angles does a transversal make? 8. Right? It makes 4 on the top and 4 on the bottom.
A line that intersects two or more.
Yep. Yeah, probably. All right, a line that intersects. Sorry, I was typing quick. Yeah. Oh, no, that's not what I wanted to do.
When somebody reads it, they're going to be saying the same thing.
Here we go. Now, one thing about transversal, some people get stuck on thinking that the transversal has to be vertical. Is this still transversal if I turn this sideways? Is it still transversal if it's that way? Does it matter which way it points? Is it still transversal? It just has to cross 2, right? It doesn't matter which way it crosses 2. Right. It makes those 8 angles, and we're going to take those 8 angles and we're going to give them specific names. Okay? First one, the top left one is corresponding. Corresponding angles are angles that are in the same position for both the bottom and top set of angles. Okay. See how the 6 is like in the top right corner? And the 2 is in the top right corner? Those two are corresponding, right? We always want to pair, when we're talking about these type of angles, we always want to pair one from the bottom 4 to the top 4. Okay. So corresponding is going to be at 6 to 2 because they're both in the top right spot. Here is it angle 8. Which angle would be corresponding to angle 8? 4, right? Because it's the one right here, because they're both bottom right. And so on with the other ones. Over here we have alternate interior angles. If we look, these angles are on the inside of those two lines, right? Is it up on the board? If I put it up on the board, then you can get it. If not, you're going to have to wait. Okay. So here we have alternate interior angles. If we look, they're both on the inside, right? They're both on the inside. They're on alternate sides of the transversal, right? So one's on one side of the transversal, the other's on the other side. They're both inside, making them alternate interior angles, okay? What would be the alternate interior angle of angle 6? Yeah, 3 over there. This one over here, consecutive interior. Again, they're inside, but instead of being alternate, like we were over here, they're consecutive, so they're on the same side. So over here, if I have angle 4, that's going to be a consecutive interior angle with which one? 6. Oops. That's a 6. And the last one is alternate exterior. This one, they're on the outside. Right, outside. One's on the left side of the transversal, one's on the right side of the transversal. So we have 1 and 8. What about angle 7? Which one is that paired with? 2. Okay, good. I would definitely suggest you putting these into your notebook, even if you think you got them down. Okay? You don't want to get stuck on a quiz or a test because you thought you knew them. Sure you don't want me to press it? This is on page 149. Okay, page 149 of your book. If you need to finish them up, I'll let you guys finish them up when I'm done talking. All right? Here, example 3. I want you guys to give me all of the angles by the types. So if we look at corresponding, all right? Corresponding. Griselda, give me a pair of corresponding angles. Two and 4. Remember, we always want to pair, see how there's 2 groups? We always want to pair one group with the other group, okay? So if we're picking, did you say 2? If we're picking 2, which other one do we need to pick? For corresponding? See how this one's in the top right corner? We're going to pick top right corner. Okay, so 2 and 6. Okay, Darren, give me another pair.
3 and 7.
3 and 7. Good, those are both lower lefts. Dylan, give me another pair. So we'll go with 5, but we can't pair it from the same side, right? So we need to pair 5 with one of the ones over here. Try again. 5, 1. Top left corner. Top left corner. Okay, that's corresponding. And then let's go with, top left, 5 and 1. All right. And let's go with Brenda. What's my last pair? Corresponding. 8 and 4, okay? So we did corresponding in green. Alternate interior, okay? Alternate interior. Let's ask Kyle, can you give me a pair of alternate interiors?
4, 7.
4, 7, are they alternate?
No, 4, 8.
8's not interior, there we go, 4. So we go 4 and 5 are alternate interior, okay? They're on either side and they're on inside, all right? TJ, can you give me another pair of alternate interiors? TJ. Somebody tap TJ. TJ, thank you. Can you give me another pair of alternate interiors? 7, I'll take. 6 is outside, though. We're not going to take 6. 3 is also outside. So these are outside. So we have 7 and what? 2. Okay, alternate sides of the transversal inside of the 2 lines. All right, so we did alternate interior in red. Let me clear up some space, and then we'll go to blue. Alternate exterior, okay? Alexis. 1 and 8, good. Jesse. 3 and 6, good. Consecutive interior, okay? Draven. 2 and 4, they're kind of consecutive, they're kind of interior, but remember, we have one group of angles and another group of angles. You need to match one to the other group. So let's look at 2. Which one matches with 2? 5, there we go. That's interior, right? Consecutive interior. Right, that's what you did the first time, right? Linker, what's the last one? 7 and 4. Okay, good. Here's you guys' homework assignment. Yeah, that was the last one. That was the one you just did. All right, here's you guys' homework assignment.